Hey guys, it's Miss Clemons here, and we're going to go over page 185 and 186. Go away, please. Thank you. Which is on lesson 17 about finding equivalent fractions. So, if we look at our example, it shows us these two bars are the same size, but the parts are different sizes, but the same amount is shaded on each bar. So you've got 1/2 shaded here and 3/6 shaded here, and that shows us that 1/2 and 3/6 are equivalent fractions. Now we're going to shade the bars on questions 1 and 2 to model equivalent fractions that are shown on the side. So for question number 1, we're shading in 1/2. So we're just shading in one out of the two parts. And on the second part of number 1, we're going to shade in 2/4. 1, 2. And we can easily see that that covers the same amount of space. For question number 2, we're going to shade in 2/8. Make this a little bit wider. Maybe this will go faster. There we go. And 1/4. Oh yeah, that's better. And we can see that 2/8 and 1/4 is the same amount. So those are equivalent. Now, looking down at question number 3. For question number 3, it wants us to write the equivalent fractions that the bars show. So let's make this a little bit smaller again. And on this bar, we can see that 2 parts are shaded, and there are 3 parts total. So that fraction is 2/3. And then on our bar underneath, we can see that 1, 2, 3, 4 parts are shaded out of 5, 6 total parts. So 4/6. So that shows us that 2/3 and 4/6 are equivalent. Right, going down to page 186. Shade to show the fractions. Are the two fractions equivalent? Yes or no? So this time it's not telling us. We have to figure it out. So let's make my coloring a little bit bigger. 1/2. Okay. There's 1/2 shaded, and down here 1/3. Are those equivalent? Well, if I bring my little mouse up here, I can see, no, those are not equivalent. 1/3 is definitely smaller than 1/2. So over here, I'm going to check. No, they are not equivalent. Question number 5, I'm going to do 3/4 and 6/8. So 1/4, 2/4, 3/4. And over here, I'm going to do 6/8. 1, 2, 3, 4, 5, 6. 6/8. So, and I didn't color these in the same direction, so that makes it a little bit harder to see. So actually, let me undo that part. Undo. Let's color that again. Let's try to color it in the same direction to make it easier for y'all to see. So I can see that this whole top half is shaded. There's 4 of my 8s. Then 5/8, 6/8. So is that the same amount? Yes, it is. So those are equivalent. Number 6, 4/8. 1/8, 2/8, 3/8. Just pretend like that whole thing is shaded. And 4/8. And down here it tells us 1/2. So that means 1 out of my 2 parts. Okay, and do those line up? Yes, they do. So 4/8 and 1/2 are equivalent. Check yes. All right. use the bars to show that 2/3 is not equivalent to 7/8. So now I have to I'm going to come over here and change to my actual line drawing because we need to be precise here. If we're not precise, it's going to be really easy to make mistakes. So first we want to do thirds. Well, I know half would be about here. So when I'm thinking about thirds, I always find my half first, and then I just go a little bit this way, a little bit this way. And I'm looking at it, and it looks like my middle bar is large. So I'm going to just move that over just a bit. There we go. That looks pretty good. Looks about like thirds. And now for my bottom bar, I need to use eighths because that's my fraction unit is eighths. So for eighths, I always start with a half. And then I look at each half and do those in half because it's always easy to do something in half. You know, it's just 2 equal parts. So that would be about half of that. And that looks pretty good. And now to make eighths, I'm going to look at each fourth and cut that in half. So this section in half. Now move to this fourth, cut it in half. This section, cut that in half. This section, cut it in half. And that looks pretty good. This one's a little bit funky, so we'll kind of move him around. And you might be a little bit better over here. Remember, we're trying to be precise. We don't have to be always so precise when we're shading, but when we're actually partitioning, we do need to be precise. So I think that looks pretty good. It's definitely not perfect, but I tried my best. And now we're going to shade because it said use the bars to show this. So I'm going to my drawing tool and let's change the color just for fun. And I want to show 2/3. So that means that 2 of my 3 parts are shaded. So there's 1/3, 2/3. Okay, and then down here, I want to show 7/8. So that's 1, 2, 3, 4, 5, 6, 7. So that means I need to shade all. Pretend like I got that inside the box. I'm not using my line tool right now. Forgive me, I'm drawing with a mouse. I wish I had Sal's cool little pen that he uses on Khan Academy. Make it look better for y'all. Okay, so now we can very easily see that 2/3 is not equivalent to 7/8 because 7/8 it looks like is greater than 2/3. 2/3 is actually less. Now we have to explain. So let's think about that. So we want to show that 2/3 and 7/8 are not equivalent. Well, if I look at these, it wants me to explain my drawing. So we're going to come over here and we're going to use words to explain. I'm going to say the top rectangle is partitioned into 3 equal parts with 2 parts shaded. And I'm going to say what I did on the bottom. The bottom rectangle is, spelling, let's right click and spell that correctly, is, I'm going to use my math language again, partitioned into how many equal parts? 8. Into 8 equal parts with 7 parts shaded. Now, how are they not equivalent? Instead of they, let's be specific. 2/3 and 7/8 are not equivalent because, why are they not equivalent? Well, because 7/8 fills up more of the rectangle and 2/3. There we go. We've answered our question. And I believe, let me get my face off of here. Oop, let's spell that right. I use THAN because we're comparing. Oh, and I should end with a period. Because even though this is math, we use our sentence structure. And that is the end of page 185 and 186. Have a great day. Remember, ask any questions on Google Classroom or on your Class Dojo. Bye, guys.